All right, let's dive into the anatomy of the most personal computer you own, your smartphone.
Think about it. It's our connection to the world, it's our camera, our entertainment console. It's pretty much everything. But how often do we actually stop and think about what's really going on inside this little slab of glass and metal?
And I mean really works. You know, from the moment you hit the power button to that split second a photo just appears on your screen, what is happening under the hood? Well, that's exactly what we're going to unpack.
And this framing right here, it's the key. You gotta stop thinking of it as just a phone. Instead, think of it as a whole collection of specialized computers all working together in concert. It's a complete system, and once you see it that way, everything else just clicks into place.
So here's the big idea. A smartphone isn't just one single thing. Not at all. It's a stack of super tightly integrated subsystems, like a whole team of specialists, all being managed by a brilliant conductor. And we're going to peel back those layers, one by one, starting with the physical world.
Let's start with the stuff you could, theoretically touch. The silicon chips, the sensors, the battery. This is the bedrock, the physical foundation that all the software magic is built on top of.
At the absolute heart of it all is something called the System on Chip, or SoC for short. This is the brain. And it's not just one processor, it's more like a committee of experts. You've got the CPU, which is like the master logistician, just running the core instructions and the app code. Then you've got the GPU, the visual artist, whose whole job is to paint everything you see on the screen. And more, you've got the NPU, the AI specialist, which is dedicated to brainy tasks like face unlock or making your photos look amazing.
Okay, let's clear something up that trips a lot of people up. Memory versus storage. They are not the same thing. Think of RAM, that's the memory, as your temporary workbench. The more space you have on your workbench, the more projects you can have open at once without everything getting cluttered and slow. Storage, on the other hand, is the permanent filing cabinet. That's where you keep your operating system, all your apps, and your photos for the long haul.
And of course, the phone needs a way to interact with the world, right? It's got senses, just like we do. Sensors that can detect motion, where you are, and light from the camera. It communicates through its radios, cellular, Wi-Fi, and Bluetooth. And obviously it has its window into the system, the display, and its heart, the battery, which is pumping power to every single one of these components.
So what actually happens when you press that power button? Well, in a fraction of a second, this incredible invisible dance kicks off. A tiny piece of code that's hardwired right into the chip starts everything. It loads the bootloader. That bootloader then wakes up the core of the operating system, which in turn initializes all that hardware we just talked about. And only then does your home screen finally appear, ready to go.
Okay, so that's the hardware, all the physical instruments in the orchestra. But now we need to talk about who's conducting this whole thing. If the hardware is the orchestra, then the operating system, well, that's the maestro, the invisible conductor, making sure every part plays in perfect harmony.
Just think of the OS, whether it's Android or iOS, as a kind of city manager for your phone. It's the one deciding which app gets to use the CPU right now, how much memory each little process gets, who has permission to access the camera, all while keeping everything secure and running smoothly. It literally manages everything. And the OS itself isn't just one big blob of code. Nope, it's built in layers. Way down at the bottom, you've got the kernel. That's the deep-level bridge talking directly to the hardware. Right on top of that, you have something called the hardware abstraction layer, which acts like a universal translator so app developers don't have to write code for every single specific component. Then you get system services for things like notifications and location, then a framework of tools for developers, and finally, right at the very top, are the apps you actually tap on and use.
So, now we've got our hardware orchestra and our OS conductor. Let's talk about the performance itself. How do your apps actually run and create the experience that you see and feel? So here's a key idea you might not realize. Your apps are not always running the way you might think. The OS is constantly and very cleverly managing them. When an app is on your screen, it's in the foreground, getting all the attention. The moment you switch away, it might get paused in the background or stopped completely to save resources. And if the system really needs more memory for what you're doing now, it might just kill that other app and remove it from memory. It's an incredibly efficient system.
And that's what makes multitasking on your phone fundamentally different from, say, a desktop computer. A desktop tries to give every open window full power all at once. But a smartphone, to preserve that precious battery life, gives almost all of its attention to the one app you're looking at right now. Everything else in the background is intentionally and smartly limited.
Okay, time to put it all together.
Let's trace the journey of a couple of everyday actions just to see this incredible system in motion. This is where the magic happens.
When you take a photo, you think you're just tapping a button, right? Oh, it is so much more than that. The camera sensor captures raw, messy, noisy light data. Instantly, a dedicated chip called the image signal processor jumps in to clean it up, correct the color, and merge different exposures for HDR. Then that NPU, the AI specialist, might step in to intelligently sharpen details or recognize a face. All of this happens in the blink of an eye before that final beautiful photo gets saved to your storage.
Or what about face unlock? It feels instant, doesn't it? But here's the split-second dance. The camera captures a bunch of data points from your face. The NPU runs a super complex machine learning model to see if it matches the secure data that's already stored on your device. The OS verifies that the match is legit, and only then does the device unlock. That's hardware, AI, and software working in perfect, secure harmony.
So if you remember one thing from all of this, let it be this simple mental model. A smartphone is a team. The hardware components, the chips, the sensors, those are the players on the field. The operating system is the coach, calling the plays and managing the whole team. And the applications? Well, that's the final performance that you, the audience, actually get to see and interact with.
And that leaves us with a really fascinating question, doesn't it? We've just seen how all these components work together today, but as the hardware gets smarter with on-device AI and our connection to the world gets faster with 5G, what new capabilities will this incredible computer in your pocket unlock next? What's that performance going to look like tomorrow?